In this section, we're going to start talking about the concept of dependency injection and providers in Angular. As an application grows beyond one module, then we need to deal with the issue of dependencies. But what is a dependency? That's quite simple really. When module A in an application needs module B in order to run, then we say that module B is a dependency of module A. And realistically, when writing applications, we can't get away from building numerous dependencies between different parts of our code. For example, let's imagine we have a class of email sender like the one on the screen right now. In the constructor for email sender, we create an instance of a concrete MailChimp service. I've left out specific functionality. This is just for demonstration purposes. And then in our email sender class, we have a send email function which forwards the send email request to the specific service that we're using. So right now we're using the MailChimp service. And then to use this, we instantiate a class of email sender. And then we just call send email and we pass it some sort of mail object which we wanted to send. But what's wrong with this code? One of the things that's wrong with it is that it's inflexible. It's hard to reuse in other configurations. We've actually hard coded the MailChimp service as the email service that actually sends the email. What if we wanted to use the email sender with another service, perhaps a SendGrid service or another provider, another mechanism of sending emails? How would we actually be able to reuse this class to do that? And the answer is, well, we couldn't. It's hard coded just to use the MailChimp service. Another problem with this code is that it's hard to test. How do we actually test this? Calling send email, the send email function, actually sends a real email to a real email address using an external service we have no control over. How do we actually test that calling send email really tries to send an email? And the third thing that's wrong with it is that it's brittle. It's hard to maintain. If we ever changed our API key, for instance, so we've hard-coded our API key for our MailChimp service here, we then need to make sure it's changed in every single instance we've used the mail service. So just by changing the API key, our code here will fail. But even if we put the API key in a global configuration object somewhere, what if the MailChimp service just fundamentally changed how it performed authentication? And instead of using an API key, perhaps we decided to change it to use a username and password combination. Then again, the email sender is going to break because we've assumed the MailChimp service is using an API key. What I'm describing here is a concept called tight coupling. The email sender class is said to be tightly coupled with the MailChimp service class. And this makes the code inflexible, hard to test, and brittle. Now, we can't actually get away from the fact that the email sender class needs the MailChimp service class in order to function. The MailChimp service is a dependency of email sender. But we can change the code so that it's easy to reuse, easy to test, and easier to maintain. So the only change that we've made really is that now we're passing in the email service to the constructor for our email sender. And then when we construct our email sender, we're just creating a new instance of MailChimp service and just passing it in. So previously, the email sender was responsible for creating an instance of its dependency, the MailChimp service. Now something else is responsible for creating the instance of MailChimp service and then passing it into the email sender via its constructor. So if we wanted to create an instance of the email sender class, we now need to pass in all the required dependencies in the constructor. The email sender doesn't make any guesses as to what dependencies it needs or how to instantiate its dependencies. The dependencies are now said to be decoupled from our email sender class. But how does this decoupling help us with our 3 points? Well, now our code here is more flexible. It's easier to reuse. We can reuse the email sender class, but with a different email service. For example, if we wanted to use the SendGrid service instead of the MailChimp service. As long as the SendGrid service still has a function with the signature send email, we can pass into the email sender constructor an instance of SendGrid service instead of MailChimp service, just like this. The email sender class itself doesn't need to change just because we're using a different service for sending emails. Also, this code makes it easier to test. We could create a dummy email service, something which doesn't actually send emails, but does let us check to see if the send email function was called. For example, we might create something called a mocked email service. It still extends email service. It still has a send email function, but it doesn't actually send an email. It just sets a flag called mail sent to true if that function gets called. And then if we just wanted to test our code, we can pass in an instance of the mocked email service into our email sender class. Or if we were using this specifically in a test, we might do something like this. So we would create an instance of our mock service, pass that into the email sender, and then in our test we'd call send email. And then we could just literally check to see whether the mock service.mailSent is equal to true, and hopefully that would make our test pass. So now our code is easier to test, but it's also easier to maintain. Since the email sender class isn't responsible for creating concrete instances of the email service, if, for instance, the MailChimp service required some new configuration, then the email sender class isn't affected. For instance, if we decided to use, instead of an API key, a username and password combination to call the MailChimp service API, as long as the MailChimp service still implements the send email function, how it's constructed and configured and functions internally is of no concern to the email sender class. All it cares is that it's getting past something with a send email function. Now, this idea of moving the responsibility of creating the concrete instances of dependencies to something else is called inversion of control, or IOC. The specific design pattern for implementing IOC in our code here is called dependency injection. We injected the dependencies of email sender in the constructor. Now, dependency injection isn't just a concept for Angular. It's a really important application design pattern, and it's used everywhere in software development. But Angular has its own dependency injection framework, and we really can't build an Angular application without it. It's used so widely that almost everybody just calls it DI. And the DI framework in Angular consists of 4 concepts working together. Firstly, we have something called a token, and this uniquely identifies something that we want injected, the something being a dependency. We also have a dependency, and this is the actual code we want injected into something. We have the concept of a provider, and this is a map between a token and a list of dependencies. And finally, we have an injector. And this is a function which, when passed a token, returns a dependency or a list of dependencies. And the act of passing a token into the injector and returning a dependency or a list of dependencies, that's also called dependency resolution. The objectives for what we want to learn in this entire section is how the Angular DI framework works under the covers, what are injectors and child injectors, what function do the inject and injectable decorators play in the dependency injection framework, what are the different types of dependencies we can inject in Angular, and how to configure dependency injection in Angular with Angular module providers, component providers, and component view providers.